going to do in this video is see how we can approximate limits graphically and using tables. In the future, we're also going to be able to learn techniques where we're going to be able to directly figure out exactly what this limit is. But for now, let's think about how to approximate it. And it'll build our intuition for even what a limit actually is. So we want to know the limit as x approaches 2 of x to the third minus 2x squared over 3x minus 6. Now, the first thing you might want to check out is, well, what is this expression equal to when x is exactly equal to 2? And we could do that by substituting x with 2. So it'll be 2 to the third power minus 2 times 2 squared over 3 times 2 minus 6. Well, this numerator over here, this is 8 minus 2 times 4 minus 8. So that's going to be equal to 0. And then the denominator over here is 6 minus 6. Well, that's 0. And we end up in the indeterminate form right over here. So this expression is not defined for x equals 2, but we can think about what is the expression approach as x approaches 2. And first, let's think about it visually. So if we were to graph it, and I graphed this on the site Desmos, which has a nice graphing calculator, you see the curve y equals this expression right over here. So this is the curve of y is equal, let me do that in a darker color. This is equal to y is equal to x to the third minus 2x squared over 3x minus 6. And you can see, at least everywhere where I've shown it here, and it's actually true, it's defined everywhere except for when x is equal to 2. And that's why we have this little gap over here showing that it is not defined. And so what I want to do is I want to approximate, well, as x gets closer and closer to either from lower values of 2 or from larger values of 2, what is the value of this expression or the value of this function approaching? And at this level of zoom, it looks like it's approaching this value right over here. So as x gets closer and closer to 2, it looks like our function is getting closer and closer to that value there, regardless of which direction we are approaching from. And so just approximating it visually right over here, let's see. This is 0, this is 2, this is 1 right over here. This would be 1.5. At this level of zoom, it looks like it's about 1.3 or 1.4. So 1.3 or 1.4. Let's zoom in a little bit more. And if you have access to a graphing calculator, or you go to a website like Desmos or Wolfram Alpha, you can zoom in further and further on this graph. So I encourage you to try that out yourself, or would do it with other graphs. So let's zoom in even more. So once again, we're not defined at x equals 2. But here we get a slightly better read. Let's see, this is 1, this is 2. The value that we are approaching, as x gets closer and closer to 2, we're getting our values getting closer and closer to that right over there. And if we look at what y value that is, let's see, if this is split into 1, 2, 3, 4, 5. So this is 1.2 right over here. This is 1.4 right over here. So it looks like it's between, so this would be 1.3 right over there. So it's a little bit more than 1.3. So a little more than 1.3. So approximately 1.3. Let me now do that in a lighter color. So it's approximately 1.3 something, it looks like. Let's zoom in even more to see if we can get even a better approximation. So now, once again, we're approaching that same value. We're not defined at x equals 2, but as we are approaching x equals 2, let's see. Let me get a darker color. So it would be right around there. And this is, let's see, this is 1, 1.1, 1.2, 1.3, 1.4, 1.5. So once again, it looks like it's about 1. If I were to just base it off of this, looks like it's about 1.333 or 1.34. So I'd say maybe approximately 1.33. So approximately 1.33. If I were, it looks like it might be approaching 1 1/3, but we don't know for sure. Remember, when you're trying to figure out a limit from a graph, the best you can really do here is just approximate. Try to eyeball. Well, the closer x gets to 2, it looks like this function is approaching this value right over here. Now, another technique, which tends to be a little bit more precise, is to try to approximate this limit numerically. So let's do that. So let me get rid of these graphs here. We already got a sense of what the graphs can do for us. They got us to about 1.33. But now let's try to do it numerically. So I'm going to set up a table here. And I encourage you to do the same. And so on this column, I'll have my x. And on this column, I'm going to say, well, what is the expression x minus 2x squared over 3x minus 6 equals? And we know that when x is exactly equal to 2, that this thing right over here isn't defined. But let's see what happens as we approach 2. So let's see what happens when we're at 1.9 or 1.99. Well, I'll do 1.99. I'll also do 1.999. And we could also see from the other direction. We could say, well, what happens when we approach at 2.001 and see if we are getting, if both of these values seem to be approaching something. And so this is approaching it from lower values of x, and then we could say this is approaching it from higher values of x. We could say 2.1 right over here. So let me get a calculator out and evaluate these. And I encourage you to do the same. Get a calculator out and see if you can evaluate these things. All right, so let's see if we can evaluate it when x equals 1.9. It's going to be 1.9 to the third power minus 2 times 1.9 squared. 1.9 squared is equal to, so we get that value, and then we're going to divide by, we're going to divide by 3 times 1.9 minus 6. And that's going to be equal to, looks like it's about 1.203. So I'll just write approximately 1.203. Now let's try it with a much closer value of x. So that was just 1.9. Now let's go to 1.999. So once again, we're going to have 1.999 to the third power, and then minus 2 times, open parentheses, 1.999 squared, close the parentheses, is equal to, so that's my numerator, and then my denominator, so divided by, and now open parentheses, 3 times 1.999 minus 6, close my parentheses, is equal to 1.332. So this is interesting. So approximately 1.332. So numerically, I seem to be approaching that same value or close to that same value that I was approaching graphically. And we can also do it from values of x greater than 2. Let me get my calculator back. And I'll do some of it. And I encourage you to finish this up on your own. And you could even try 1.999999 to see what it actually is approaching. So for example, if I wanted to try 2.1, so that would be 2.1 to the third power minus 2 times, open parentheses, 2.1 squared, and then close parentheses is equal to, that's my numerator, divided by, open parentheses, 3 times 2.1 minus 6, close parentheses, that's my denominator, and I get 1.47. So approximately 1.47. So now you can think I'm getting closer and closer to from values larger than 2. Let's see if we seem to be approaching the same value. So now let's get even closer to 2, 2.01. And I'll do this one, and then I'll leave it up to you to think to see if you can get even more precise. So actually, let's get super precise. Let's do 3 zeros here. 2.0001 to the third power minus 2 times, open parentheses, 2.0001. So we're getting really close. Squared, close parentheses, is equal to, so that's my numerator, divided by, open parentheses, 3 times 2.0001 minus 6, this is my denominator, is equal to, notice we're getting closer and closer and closer to 1 1/3. 1.3333, now 5. So I'll say approximately 1.333. And this is now for, this is actually for 2.0001. So it does indeed look like we are approaching 1.333333, or close to, it looks like we are approaching 1 1/3. But once again, these are just approximations, both through the table or graphically. If you want to find the exact value of the limit, there are other techniques, and we're going to explore those techniques in future videos.